Okay, so the next step is to trigger these guys into Ragdoll when they get hit by a bullet. How would you do that? One way would be to measure how far a bullet is from an agent, and if it's close enough, that will trigger him. The problem is that the bullets are going so fast from one frame to another, and the bullet might have gone through an agent between two frames, but it won't be an actual frame where the bullet is close to him. So what I'm going to do instead is that I'm going to take the point position, and then I'm going to raycast back to his previous position. And if any agents gets hit when I'm doing that, then I know that that agent is supposed to be in Ragdoll. So to do this, I need to have a point position to raycast, and then of course I have the bullet position, and then to raycast backwards I'm going to use the velocity that I just need to do some modification to. So let's go into the tracer fire. I'm going to drop down an attribute up here. I'm going to select that guy. Let us just visualize the velocity first. So I'm going to click X and click on this velocity here, and in here I'm going to set this to marker and then to vector. And if we look at this, we have these very long vectors. The reason for that is that velocity is in seconds, so it's how far this particle will travel within a second. But when we are raycasting backwards, we just care about one frame. So what you need to do then is we need to divide one with whatever frame rate that we have. In this case, it's 24 frames per second. So if I do a constant 1, and another constant 24, and divide this, we get this fraction that we can multiply the velocity with. If you're multiplying a vector with a float, that will drive the length of the vector. So if I would, for example, multiply it by 0.5, the magnitude of that vector would be half of what it was before. If I do this here, multiply in here, you can see that suddenly I have much shorter vectors. Now you just get the length that is travel each frame. We still need to do a final thing though, because this is of course going forward. We want it to be pointing backward. Luckily it's really easy to do with vectors, so the only thing you need to do to reverse a vector is to multiply it by -1. So let's drop down another constant and set this to -1, and voila, now it's pointing backwards. Cool. So let's export this value out. So I'm gonna drop down a bind export, and I'm gonna set this to vector, and then I am going to call this ray direction. Right, let's go to the agents. So if we go into the crowd simulation here, I'm going to drop down the subsolver, and I'm going to connect that into the multisolver here at the end. The subsolver lets you do sub operations within a DOP-sim. Here we are in the subsolver, and now we just need to get the bullets into the simulation, so let's drop down an object merge. And then I'm going to point to the tracer fire. So here are our bullets, and then going to drop down an attribute VOP here. So here is our attribute VOP, and I'm going to connect the agents to the first port, so that means that this will iterate over the agents, and then I'm going to put the bullets into the second port. But in this case, we also want to iterate over the bullets. It's good that we iterate over the agents, but also for each agent we want to iterate over the bullets and see does it hit me, and if it does hit me, then we're going to trigger it into Ragdoll. So a way we can do this is to use a for loop. So if we drop down a for loop, and in a for loop you can specify a length, and then it will iterate that many times. Another thing you can do with it is you can put a value in here, and then you can modify that value and get it out here, and then it will remember that value over the next iteration, which is very handy. So what should we use for length? Well, we want to loop over each bullet, so let's count the bullets, and we can use that with a point count. And I'm going to take the second input here, because as you remember, here is our bullet coming in, and then I'm going to set this to the length. Great, so now we have one loop for each bullet, so let's do an intersect, which is a raycast. So before moving on, let us just talk about the intersect node. So I have this little setup here. I have a point, and then I'm raycasting down on this grid when it intersects. So if we go into this attribute VOP, we see I have an intersect, and I'm using the point position as a ray origin, and I also have a ray direction, and that is -1. One thing with intersect that is different from a ray node is that this ray direction is actually the length as well. So if I would go and move this, now it's 0.7, if I would move this over 1, like this, then suddenly it doesn't intersect anymore. If I would go in here and change this to -2, for example, then the actual ray is long enough again. So what you get from an intersect node then, you get the position where it intersects, and you also get a primitive number and a UV. And the primitive number would be the polygon that you are hitting. If you are hitting an agent primitive, then this prim number will be the number of the agent, and you won't get a UV anymore. So okay, let's go back. And we want to intersect with agents, which are in the first port here. And then we need a ray position and a ray direction. Let's import those. If we take import point attribute, by default is for point position here, so let's use that first. I'll get the points from the second input, which is what the bullets are connected to. For the point number, let us use the index number that will count up for every iteration. As we know that there will be as many iterations as points, this will give us every point number. And then let's put that into the ray org. Then we need one for the direction. So let's use this ray direction that we created before. And then connect that into the second port here. So cool. Now we have something that's go through each agent and each bullet and see if there is any intersections. If there is an intersection, we're going to get the primitive number of the agent that gets hit. So in that way, we know that if the current primitive number is equal to this one, then it's hit. So let's do a compare here and compare the primitive number. And now I'm going to compare it with the point number. Let's make a two-way switch here. So if it's getting hit, we want it to be set to 1. So I'm going to drop down a constant here. I'm going to set to 1 and put that in here, the top one, which is true. And then I'm going to plug that into the end here because we want to write out that value. And as you might recall, like I said in the beginning, this value that I'm setting here will be remembered. So I'm going to set a constant here, and then I'm going to start on 0. And because this starts on 0, if this is false, I want it to be 0. But it might be in the case that it's been hit by another bullet. Then I don't want to erase that value. But the good thing is that if I'm using this value here, and just connect this here, it will start being 0, because that is its start value. But if this is set to 1 here later, it will remember that for the next iteration. So if it's just set to 1 once, then the output here will be 1. Let's bind export that out. If this is 1, it means that the agent has been hit. So let's call that hit. And then go out to the .NET. And here in the .NET, I'm going to drop down a trigger, a crowd trigger, and a crowd transition. And I'm going to connect that into this last port in the crowd solver, as you might remember. In the crowd transition, I'm going to have walk to Ragdoll. And here in the crowd trigger, you're going to use particle attribute lookup, so like so. And I'm going to use the attribute hit that I just created. And if this is equal to 1, then I know these guys are in Ragdoll. So let's go out and check this. Let's go back and just turn off this visualizer, like so. And then I'm going to select the end of the chain here. And if we play this, there should be some guys falling over. Yeah, it seems to work. Cool, so this is a good start, but we're gonna improve it further.